Now I'll rate this question as in moderate category of difficulty. Now the solution will be straightforward, but it will be slightly lengthy. Okay, so we shall treat things one by one. So first of all, you are given that one of the roots is common. So I'll assume the common root as A, and the uncommon roots of these equations are in the ratio 3:4. So the uncommon roots are 3b and 4b. So for the first equation, the roots can be 3a, sorry, a and 3b. For the second equation, the roots will be a and 4b. Okay, so these are the roots for the two equations. Now for the first equation, the product of the roots, in this case, it will be a multiplied by 3b, that is 3ab, can be written as c upon a, that will be equal to m. In the second equation, the product of the roots, which will be 4ab, from the equation it will be equal to 24. So from here, the value of ab comes out to be 6. And I can now put the value of AB here to get the value of M. So M will be equal to 3 multiplied by 6, that is equal to 18. Okay, so I have obtained the value of M, and that comes out to be 18. Now let's do the similar thing for the sum of the roots. Okay, so what all I have up till now, I have got the value of A into B. So A and 3b are the roots of first equation, A and 4b are the roots of second equation. The value of A into B has come out to be 6, and the value of M is equal to 18. Okay, now the sum of the roots for the first equation, it will be a plus 3b, and that is equal to minus b upon a, that is equal to 9. So a plus 3b is equal to 9, and for second equation, the sum of the roots, that is a plus 4b is equal to minus b upon a, that is equal to n. So the value of n is a plus 4b, and we have to find out the possible values of n. Okay, now for that I need the values of a and b. So I have two relations using which I can find out the values of a and b. I have this relation where the product of a and b is 6, and the second where the sum of a and 3b is given as 9. So from this equation, I can say that the value of a can be written as 9 minus 3b, and I'll substitute the value of a in the product of a and b. So 9 minus 3b multiplied by b is equal to 6 is the equation. Simplifying this equation, I'll get, I can take 3 common from here. 3 common le lete hain. So I'll get 3 minus b multiplied by b is equal to 2. So that is the b square minus 3b plus 2 equal to 0. Now solving this, you can get two different values of b. B square minus 3b plus 2 equal to 0. Solving this, you will get the value of b as either 1 or 2. Now, if b is either 1 or 2, the value of a can be calculated because I know the product of a and b. So if b is equal to 1, a will be equal to 6. And if b is equal to 2, a will be equal to 6 upon 2, that is 3. So these are two different pairs of values of a and b. Now from each of these possible values of a and b, if I substitute it in the value of n, which is a plus 4b, I will get different values of n. So for the first set, when b is equal to 1 and a is equal to 6, the value of n comes out to be 6 plus 4, that is equal to 10. So one of the possible values of n is 10. Now putting the second set of values for a and b, let's see if I get different values of n, different value of n or not. So if b is equal to 2 and a is equal to 3, the value of n will be equal to 3 plus 8, that is 11. So yes, two different values of n are obtained. So we can say that there are two possible values of n that can be obtained in this question. So the answer should be 2.